I want to talk to you today about pipeline risk management. The point of managing risk is not to eliminate risk, but to assess the critical risks and manage them. There has been a lot of attention to pipelines lately, and the number of news reports about pipeline failures is increasing steadily. Unfortunately, the news is not good. Companies are reeling from incidents like the Kalamazoo spill, the San Bruno explosion, as well as the Mayflower spill in Arkansas. Though the focus of industry is to keep the oil in the pipeline, the failures are eroding the industry's social license to operate. The catalyst to this erosion is fear, uncertainty, and doubt, spread by environmental special interest groups. Their weapon of choice is social networking. It is lightning fast and reaches out across all social demographics and has no geographical boundaries. The special interests are not interested in speaking to business executives, and they're not interested in speaking to politicians. They are interested in speaking to the public and directly influencing them, and this is having a profound effect. Special interest groups have proven themselves to be masters at social networking, whereas the industry has collectively stumbled with a predictable response. Ignore the issue, argue and deny, lobby the government, and launch a marketing campaign. This is not working. The fact is, industry is not trusted, and their marketing campaigns are met with indifference. Governments are listening to their electorate and growing increasingly concerned about the balance of the environment with the economy. It is no longer business as usual for pipeline operators or their customers, and changes are coming. So why does equipment fail? There's a perception in the industry that failures are random and sudden. Though this is true in some cases, the accumulated stresses and materials result in failures that have developed over long periods of time. Failures cost companies, workers, and taxpayers dearly. By the time a leak is detected, it is too late. The damage to the environment has already occurred, and the damage to the company's reputation as well. 1/3 of all pipelines worldwide are not able to be inspected with automated methods. The average plant in North America suffers from 180 leaks per year, 2 to 3% of which result in plant downtime. A UK study found that on average, 243 leaks occur per year offshore. Is there a way for companies, governments, and the public to come to a common understanding? We believe there is. Monitoring pipeline integrity and predicting failure is key, and the collection and dissemination of this information needs to be transparent. Scanimetrics has developed a platform that includes sensors to measure strain, fatigue, joint integrity, erosion, and corrosion, and provides a cloud-hosted service that involves automated data collection and analytics. How do we do this? One key measurement of the integrity of a material is the amount of strain it experiences. Strain is a deformation of material at the nanoscale that we've all experienced when we were kids. Take a pop can, bend it several times, and it quickly breaks in two. Every back and forth cycle is a fatigue cycle, and the accumulation of this fatigue damages the material at the molecular level. The fatigue eventually manifests itself into cracks, which leads to complete mechanical failure of the material. By measuring the magnitude of the bending cycles and counting their number, you can predict failure and reliably predict remaining useful life. Though sophisticated analytics can unlock patterns and relationships in the data that enable a deeper understanding of failures so that they can be avoided in the future. The benefits of predicting failure versus detecting failure are significant. reduction of productive downtime, a reduction of maintenance cost, and a reduction of consequential cost for environmental and health-related incidents, resulting in improved financial performance, a safer workplace, and a cleaner environment. Win-win for the industry, for government, and the public. Prognostics derived from analytics enable proactive decision support to drive value-optimized choices. In the case of pipelines, the choices may include crack repair, replacement of material, renewal or asset replacement, and retirement or dynamic inspection. Real-world examples of where this is being used include detecting stress induced in pipelines by ground movement in sloped areas, river crossings, and fault lines, cyclical fatigue in pipes due to pumping and vibration and other dynamic factors, and erosion of pipelines used to transport bitumen and slurry tailings. Flange integrity can be evaluated through the analysis of data for bolted joints and gaskets. Maintaining the integrity of flanges eliminates environmental damage due to the leaking joints. Moreover, the safety of workers is improved when integrity of these joints is maintained. Simply stated, bolted joints fail, and they can fail at any time. The resulting leaks can delay production startup, cause unplanned shutdowns, and always impact budgets negatively. They are unacceptable and can be avoided. We see a future where sensors, industrial data analytics are used cooperatively by industry, governments, and special interest groups to productively and safely operate and monitor pipelines for transportation of hydrocarbons to the benefit of all Canadians. The future is now. Thank you.